Okay, Ms. Redican here today. We're going to be going over the conservation of mass and how that leads to balancing equations. The conservation of mass says the mass of the reactants must equal the mass of the products, and we're going to apply that to find unknowns. All right, the arrow is where our equal sign will go. So 50 grams of the calcium plus 150 grams of the zinc carbonate will create 125 grams of calcium carbonate plus an unknown quantity of zinc. Okay, so let's go ahead and add up this side. 50 and 150 make the 200. And then we have the 125 plus the unknown, which I'm going to call x. To solve for x, I do the opposite of adding 125, which is subtracting. And whatever I do to one side, I do to the other. Here it cancels, and I get simply x equals 75. Okay, so at this point, make sure you have paper, a calculator, and follow along with me so that you can solve the problems. Again, we have our reactant side must equal, right, the arrow, the products. So we're going to add this side together on our calculator. And when I add those together, I get 342.6 equals the 176.5 plus our unknown amount of zinc. To find out how much it's going to make, we can simply, again, subtract 176.5 from both sides to isolate our variable. Whatever I do to one side, I do to another. Here it cancels. I end up with x equals 166.1. Okay. Now notice it doesn't matter where the x is. It can be on the reactant or product side. We have reactants equals products. This idea of boxing out and putting your equal sign is a good habit to get into. So now we have our x on the left side, our reactant side. We're going to add up those two together, 66 and 36. Let's add them up. 102. And now we have to solve for x. Again, the opposite of adding 80 is subtracting. Whatever I do to one side, I do to the other. Cancels out. So I get x equals 22. And again, these are grams. In this case, it's grams of propane. Okay, so here, as I read the word problem, we're going to apply 46 grams of reactants. So here's the reactants, and they are 46 grams together, not each, but together total. And they're asking, what will the products be total? Well, we know reactants equals products, so 46.5 grams. Whatever goes in comes out. In this problem, they're not breaking down to the individual reactants and products. They're using each side and as a sum. And let's keep going. Calculate the mass of the product. So this magnesium oxide, that's going to be our x. When 6.4 grams of magnesium, here we go, 6.4 grams, and 1.32 grams of oxygen. Here's the oxygen. So notice as I read the problem, I assign the numbers, and now I can just rewrite it. Plus oxygen. Again, our arrow is like an equal sign, x. So I'll simply add these together to find the amount of product. Because again, the mass of the reactants must equal the mass of the product. We have one last one. The mass of zinc is what we're looking for. So that's going to be our x. That reacts with 4 grams of hydrochloric acid. So the zinc we don't know. I'm going to call that x. And it's reacting with, that's adding, hydrochloric acid. If you don't know the symbol, that's fine. And that's 4.11 grams. And it forms or equals 9.1 grams of zinc and 3.97 grams of the hydrogen. And again, if you don't know the symbols, that's okay. Really just need to set up our formula. That's grams. So let's add those two together. And then I'm going to add them together. I get 13.07. So again, x plus 4.11 equals 13.07 when I add that together. Now I can subtract 4.11 from both sides. It'll cancel out, and I'll get x equals 13.07 minus 4.11, and that's a total of 8.96, and again, grams. Final answer. Okay, again, mass of reactants equals mass of the products. Now let's apply that to balanced equations. This all, of course, goes to the conservation of mass, where matter cannot be created or destroyed. Everything was made with the Big Bang. And since then, it's only been rearranged. So, again, we're going to make sure the arrow is sort of like our equal sign. So right now, we have two H's. So we have two of the H's. And on this side, we have O. We have just two of those. On this side, we have two H's right now and one O. If there's no number, the 1 is implied. So you can see right now, they do not match. They're not equal, and they need to be. We're not dealing with grams here. We're dealing with numbers of atoms. It's another way of applying the conservation of mass. We can't change the subscripts, okay? But we can change the coefficients. So I'm going to put a 2 here. Again, trial and error. We do not start on one side and go to the other. We go back and forth. Once I add the 2 here, it changes everything. Now 2 times 2 is 4 H's. And now we have 2 O's. The O's are oxygens match, but now the H's do not. I'll come back to the other side and put a 2. 2 times 2 will give me that 4. Now we have a match. 4 H's, 4 H's. 2 O's, 2 O's. Any remaining blanks are simply 1, or you can leave it blank where 1 is implied. Okay, let's try again. Again, we find the arrow. That's our dividing line for reactants and products. We have 2 H's and 1 O. On the product side, we have H, there's 2 of them, and O, there's 2 of them. Again, they don't match. We need more O's, so I'm going to add a 2 here. That's going to change both the H's. So the H's are now 4. The O's are now 2. The O's match, the H's do not. I'm going to come back here and put a 2. 2 times 2 is what's giving us the 4. So for our reactant side, we have 4 H's and 2 O's. And our product side total, 4 H's and 2 O's. It is now balanced. You can put a 1 in if you like, or leave it blank. Okay. Again, I find the arrow. I have sulfur. I have 8 of those. And oxygen, I have 2 of those to start. On the product side, I have an S. I just have 1 of them. And O, I have 3. Okay, nothing here is matching. So I'm going to go ahead and again use coefficients. I need 8 sulfurs, so I'm going to put an 8 in front, which makes 8 sulfurs. But it also changes the oxygens. 8 times 3 is 24. So now the sulfurs match, but the oxygen does not. 2 times what is going to get me that 24? 12. So now 12 times 2 is 24. Now the sulfurs are 8 each, and the O's are 24. So we have an equal amount of each type of atom on both sides. Now we're done. Again, you can leave that blank or put a 1 in. Okay, we have 2 last problems. Find the arrow, draw your line. Right now we just have 1 zinc, 1 H, and this is Cl, that's not a Ci. Chlorine is Cl, and 1 of those. On the product side, again, we have zinc, just 1, chlorine, 1, and hydrogen. We have 2 now on this side. So we can see the hydrogens do not match. I'm going to go back over here. I need more hydrogen. I'm going to put a 2. That's going to change the hydrogens to 2, but also the chlorine to 2. Okay. So now I have to go back to the other side because now the chlorines don't match. I'm going to put a 2 in front to make the chlorines be 2. That also changed the zinc. Still not done. Now the zincs don't match. Go back over to the other side, put a 2. Now we have everything matching. 2 zincs, 2 zincs, 2 H's, 2 H's. I can put a 1 here. 2 Cl's, 2 Cl's. It's a back and forth process. Last one. Find the arrow, draw your line. Hg, there's one of them. O, there's one of them. On the product side, Hg, right now there's just one. O, there are 2. To make the O's match, I'm going to go over here and put a 2 as a coefficient, which will change the Hg's and the O's. So now I have to go fix the Hg's, mercury. I'll put a 2 in front. Now let's check. 2 Hg's, 2 Hg's. 2 O's, 2 O's. Again, I can leave that blank or I can put the 1 in. And now it's balanced. Okay, we're going to keep practicing this in class. Again, we're applying the law of conservation of mass where it says mass of the reactants equals mass of the products. So now let's go over and do a lab experiment. So this is something you guys can try at home. All you need are 2 little Ziploc baggies or containers, even whatever works. I just have baking soda. I just put a scoop of baking soda in 1 bag and poured a little vinegar. White vinegar, apple cider vinegar, whatever kind of vinegar you have, in another bag. And I'm going to weigh them. These are my reactants. I'm going to kind of pile them up, make sure they're on the scale. Okay. So right now it's 46.98. That's the mass of our reactants. Okay, so I'm going to let's see what's the easiest to do. I think the easiest will be to put the vinegar bag inside here. I want to zip this up, close it up, and then, if I can, let's see, or maybe I will carefully, yeah, I think that's what I'll do, without spilling, open up the vinegar bag. Don't spill it yet. Close the outer bag. I think that's going to be our best spot. And now we're going to mix them in a chemical reaction. Oh, do you hear that? You guys see what's happening? So this is a chemical reaction. Baking soda and vinegar. Getting a lot of carbon dioxide. You can see the bag is puffing up. Yeah, we're going to put it back on the scale. See if we can get it all on there. Okay. You can see, even getting all this on there, it doesn't match the beginning, right? Our mass of the reactants isn't quite the mass of the products. Where did it go? And so that's what I want you to think about, and we'll talk about it in class. Okay, write your answer in your ed puzzle. We know the mass of the reactants has to equal mass of the products. Where is the missing bit? Okay, you had a clue when you watched. You can rewatch part of this video, and we'll talk about it in class. Try this in your own kitchen. And see you later.